Hi, what I'd like to do today is to show how we do a typical quality check on a vacuum tube using Hickok Model 539B. And what I'll do for this quick demonstration today is look at a Raytheon 6AK5. And the reason I'll choose this Raytheon is I've previously tested this tube on a Chinese tube tester, the GS5A, and that's in another earlier video. And for comparison and completeness, because I've done it before, let's look here at a 6J1. This is a Chinese equivalent to the US 6AK5. This comes out of the Beijing Shuguang factory. I found these to be very good tubes. This is a military grade 6J1. And let me take the tube out and then make a couple of comments quickly. Alright, let me start warming this up. Okay. Let's look at the Raytheon tube first. It's a gray plate. You can see the two mica spacers, which have the sawtooth around their periphery, sawtooth pattern. A square type getter up at the top, a little bit hard to see probably. Alright. And on my left now, or this particular tube now, is the Chinese tube. A little bit hard to make out, but it's a 6J1, and again that's the equivalent. You can see the two mica spacers, a little bit different design for the spacers, and this has a horseshoe getter up at the top. Alright, so they're both beautiful looking tubes. Raytheon new old stock and the Chinese new old stock. The one distinguishing feature between the Chinese tube and the US type tubes is the size of the tubes. The Chinese tube 6J1 is a little bit higher, and that doesn't matter whether it's a Raytheon or a Western Electric, or let me pull a tongue sole. Alright, a little bit taller. That's one way to make sure that you can tell the difference between a Chinese tube and the US tube is in terms of the height, at least for this particular type. Alright, so let me get the Raytheon tube in here and start to warm up the filament. And while I'm doing that, I want to make a general comment. Well, this is finishing up the heating, about the Chinese tubes. I've worked in Beijing for 5 years, and one of the things that surprised me, because I was a little bit biased in terms of tube audio, what surprised me, there are some really good Chinese tubes. One of the things in China as well as Russia is that they overproduce tubes, primarily to keep people working, I suppose, from the 50s up through the early 90s. And so you can find a lot of, thankfully for us people involved in tube audio, a lot of new old stock tubes in China that have US equivalents. The key though in finding a good tube, there's some outstanding Chinese tubes. This is just like there's some outstanding European and US tubes. There are also some tubes I wouldn't give 2 cents for in any country. The key though is you need to know what manufacturer they came out of, and you need to know the production year. But I've spent enough time in Asia to try to sort through some of those problems. I happen to like the Beijing Shuguang 6J1s. There's some other brands that I like, Guiguang, but Guiguang, which is another Chinese tube brand, is getting quite expensive, the vintage tubes. But just a very quick story while this is heating up. I acquired about 10 different amplifiers, tube-based amplifiers. One was an 807 based, and beautiful sounding push-pull 807. It had in the Chinese tubes, all Chinese tubes. The Chinese equivalent is a FU7 tube, that's equivalent to our 807. And I figured, well, next trip back to the US, I'm going to take back some good old US tubes, RCAs, GEs, and I'll be able to tweak this and get it even better. Bottom line is I was disappointed. Put in the RCAs, well, didn't sound quite as good. I couldn't tweak it to sound any better either. The bottom line is that amplifier today still has the Chinese tubes in. Having said that, there are some other Chinese tubes that I don't like. It really depends upon which type of tube, what the application is, and where the tubes were actually manufactured. Alright, enough said, this is warmed up. Alright, so let's go ahead and I'll explain what we've done here. Again, a 6AK5 tube, if we look down at the roll chart, the filament setting 6.3 volts. The selector switches, which are in the middle of the panel here, should be ET1562 and 0. So those are properly set. The bias volts, I'll go over that in a moment, 1.8. The shunt should be at 0 for the 6AK5. We would press P4, and there's an on-lock and a lock option here on the Hickok. The mutual conductance is C scale, I'll go over that in a moment. And the minimum mutual conductance, the reject point for the tube, is 3150. What I'd like to do though is make a point about the mutual conductance reading on various Hickok testers. The 539 series tester gives the reject point, the minimum acceptable 3150 micromos for this particular tube. The values you would read on another tester, for example the 750 series over here, you wouldn't use this reject point over on this tester. On this particular tester, the 750 for example, line chart will give you the normal stock values. The same comment for the Hickok 600, 800, 6000 series, the military TV7 for example, or the 177, you'll get different values, and the reason is that the circuits are different. So it may be applying a little bit different plate voltage, grid voltage, or bias. So you really can't compare them. However, between the different series. However, if I handed you two 539Bs, or a 539B and a 539C, and they're properly calibrated, then you could expect your numbers for a specific tube tested on two machines would be within 5 or 10%. Alright, and that's considered good. These aren't research grade machines, but they're fantastic. A fantastic piece of equipment for evaluating the quality of the tube. But don't expect that you're going to read the same numbers. And don't go by this reject point on another tester. Alright, now let's go ahead and run a quick shorts test. The first thing you do is run through a shorts. On the Hickok tester, 539 series at least, you've got two different shorts tests you can do in terms of sensitivity. The neon lamp test, where we'd rotate in the counterclockwise fashion here. And we can also do a leakage test, where we're looking for leakage. Shorts test essentially between different elements. And that's through an ohm meter. Let's go ahead and do the neon lamp test, look for shorts. Okay, again, no shorts on that. Now let's go ahead and just for completeness, if you look at the second band of numbers down here, a little bit hard to see, but it's 50 mega ohms, 10 mega ohm, 5 mega ohm, all the way down to 0. This is 50 kilo ohms. And it's really up to, depends on the application, what type of leakage. This is a very sensitive test for inter-element problems in the tube. I typically try to make sure that I'm less than one minor division. So let's go ahead and try this. And again, the needle is rock solid, so no leakage to worry about in this particular tube. Alright. Now, if we successfully pass the shorts test, the next step is either a gas test. We can look for gas in the tube, and that's important because if you have gas in the tube, you change the conductivity of the grid, and that can have the net effect of changing resistances as well as the bias. Let me do the gas test is a bit more complicated in the 539, so let me defer that in the interest of time when we test the 6J1. So let's go directly into the mutual conductance test. As I mentioned, we're on function switch position C, which is 15,000 micromos. Let's go up to the scale here, to the meter, and you can see 6 different ranges: 3,000 micromos, 6,000, 15,000, which is for position C on the switch, 30,000 micromos, 60,000, and 600. Again, we have a range of 0 to 15,000 on position C. So we'll be looking at this 0, 2,500, 5,000, 7,500, 10,000, 1,250, and 15,000. So we're going to use the third band down. We were told on the roll chart that the reject point is around 3150. Each of these minor divisions, when we're looking at the 15,000 micromos scale, is 250 micromos. Alright, so this would be 3,000, this would be 3,500 for example here. And I typically look for, if you want a decent tube in terms of the quality of the tube, you're probably looking at something of maybe 4,000 and above. Typically if you're above 4,000, you've still got good life in this tube. Okay, so let's go ahead and do this test. And what I'll do, I mentioned earlier that we have to double check the bias when we go to run the GM test. And we have an opportunity, at least on this series of tester, to go back and trim. There'll be sag potentially in the bias, the grid bias, as well as the line voltage as the tube loads the circuit. And what we're doing here on the 10 volt scale, we're told to adjust to 1.8. So I'm at 1.8 volts. I'm reading this scale 0, 2, 4, 6, 8, 10. And you can see that we look fine. We're 1.8 volts. The other scale, 0 to 50, is for other tubes. And we also, of course, can test voltage regulator tubes. That's for this upper scale here, so let's ignore that. So we're fine here. And I don't see any sag. If we look down at the line voltage, we're right on the money at 100 volts, so fine. All right, I don't like to leave the GM switch on very long, so let's go ahead and do the reading. Okay. Pressing the GM switch again, it looks as though, at least from my angle, if I'm right on top of here, a little bit above 4,500. There's a shadow from the light above, but we're a tad bit above 4,500, so let's call it 4,500 micromos for this particular Raytheon dual stock tube. All right, I would consider that to be a good solid tube. Now let's, just for completeness, because we've run the 6J1 on the other tube tester, plug this one in. Again, because these are roughly equivalent tubes, for all intents and purposes equivalent, we have the same roll chart settings, so everything is set up. Let's go ahead and run a shorts test. Again, let's do the neon short test first. Looks fine. And for completeness, let's go ahead and do the leakage test. And again, I'm looking at the second band here. We've got mega ohms. Okay, needle is rock solid, so no shorts to worry about. We can go on to the next test. Let's go ahead and run the micromos test. And again, this tube may load the circuit just a little bit different, so we always have to go back and double check with the correct bias volts. We'll look at, we're right on here. The line volts, 100 volts, we're right on here. If I come back up here now, and again we're reading the third band down, and I'm getting 5,500 right on the money for this particular 6J1 tube. Alright, so I would consider this to be a good quality tube also in terms of the GM value. Now the last test that we have to run on all the tubes will be the gas test. Well, you wouldn't run this on all tubes, but at least for the 6AK5. On the 539 series, it's a bit more complicated. It's a very sensitive gas test, but what we have to do is go to position, function switch position D for the gas test. We're not going to be reading micromos though. Rather, if we come back up to this scale, we're going to be reading the band 0, 500, and 1,000. Just think of those as relative numbers now. Alright? And what we're going to be looking for, once we set the needle to 500, is to make sure that we don't have more than 2 divisions in deflection of the needle once it's settled back down. A bit more complicated though, because now I've got to go to a bias range of 50 volts. I've got to go back and now press the gas button, P5, so I'll hold the gas button in, a little bit awkward, and I've got to adjust this using the bias volt knob back down to a scale reading of 500. So it looks like I'm okay there. You don't have to be perfect on this. Alright. Now to do the gas test, I simultaneously press button P6, which is also labeled gas 2, and I'm looking for deflection in this, and there's a charging capacitor here, so it'll deflect momentarily. Hardly any movement in this case. So long as we're less than 2 minor divisions, we would consider it to be acceptable. And so no problems with gas in this particular test. The reason that I say it's a bit cumbersome is that if we're going to do 100 of these 6AK5 tubes and we run the gas test, well, we've got to go back down now and reset our settings. So you've got to be careful you don't forget. And so it's a bit cumbersome to run the gas test in 539 series testers, but it's also extremely accurate. And again, gas is important because you can change the conductivity up in the grid. So I think that's good enough. Sorry it took so long, but I wanted to show you a few of the features of how we do a quality test, at least on the Hickok 539B. Again, it's an outstanding tester. These testers are still, from time to time, you'll see them available on some of the audio sites or on eBay.